Introduction. The heat pump is a device that pulls the energy out of air for the purpose either heating or cooling a space. It will transfer heat from a lower temperature to a higher temperature by taking work energy from surrounding. Heat pump use a system that transfers thermal energy from a heat source to a heat sink by using energy. It able to move thermal energy in opposite direction of heat flow. It's against second law of thermodynamics, which heat energy will always flow from a higher to a lower temperature. It provides efficient and economical heating in winter and cooling in summer. Also reduce energy costs of oil and electric.
The heat pump component. The first component is refrigerant. The refrigerant is the liquid or gas substance that absorb or transfer or release heat. The next component is reversing valve, which is the follow path of the refrigerant. Next is the coil. The coil is a loop of tubing that heat transmission take place. Okay, the fourth component is the plenum. The plenum is the air compartment for the distribution through the house of heat or cool air. The next component is evaporator. It used that absorbed by refrigerants boil to form low temperature vapor. The sixth component is the expansion valve to lower the compressor generated pressure. Next component is condenser. Condenser is the coil that released by the refrigerant into its atmosphere and become liquid. Okay, the last component, as we know, is the compressor. To squeeze together the refrigerant gas molecule, temperature increase. So the component is first refrigerant, second reversing valve, next the coil, fourth the plenum, evaporator, the expansion device, the condenser and the compressor.
How a heat pump works? Heat pump works by electrical load. Heat pump use freely available heat energy by moving it to where it's needed, but moving it takes some energy. The components of the system that require power include the compressor, fan, pump and control. First, air from outside that warmer than liquid refrigerant was drawn outside the fan through heat exchanger. The exterior heat exchanger called liquid refrigerant is warmed by outside air and evaporates as its temperature increases. Next, it flows to compressor. As the pressure of the gasified refrigerant increases, the temperature also increases. The reversing valve changes refrigerant direction for heating or cooling cycle. The heat pump cooling mode. The reversing valve allows the whole system to run in reverse, extracting heat from the home interior and releasing it to the outside. Number 4. The interior heat exchanger. Hot gasified refrigerant release heat to inside air and condense to a liquid as it cools. Go to number 5. Expansion valve. As the pressure of the liquid refrigerant drops, the temperature drops further.
Type of heat pump. First is air source heat pump. It transfers heat between house and outside air. It has high efficiency which humidity better than traditional air conditioner. Second is geothermal heat pump. It's transmitting heat between house and the land or a nearby water source. It has a low operating cost. It can reduce energy usage 30% to 60%. It can control moisture and fit in wide range home. Third is absorption heat pump. It is called a gas-fired heat pump. It is also the modern form of heat pump. It uses heat as a source energy and it can be powered by a wide range of sources. The advantage of heat pump, first is lower running cost, second is less maintenance, third is safety. Heat pumps are safer than combustion-based heating system. Fourth is a long lifespan. The average of a heat pump lifespan is 14 to 15 years. And fifth is it provides cooling. For disadvantage, it difficult to install. Second is it have high upfront cost. The third is significant work. The phase of installation of heat pump will damage your house or garden. The fourth is carbon neutral. Heat pump are really heavily on electricity run. It means they can never be fully by carbon neutral.
For the conclusion, heat pump have received considerable attention in recent years. Since their introduction in the early 50s, they have undergone considerable development and change. Improvement to the hardware, modification and development of new cycle of extensive scientific and technical studies have given significant boost to this device. Heat pump have also found a variety of applications from start-alone system to solar assisted heat pump to waste heat recovery system. The two treatment of the heat pump basic is present in the paper, followed by a discussion of the application in a solar heating system. It observed that while heat pump either alone or as part of a solar heating system conserve considerable amount of energy in residential application, they do not seem to be economically available assumed value for economic parameter. It is evident that the life cycle cost of such a system is very sensitive to energy escalation scenarios, maintenance cost and interest rate of capital. Furthermore, effect of widespread heat pump use electric alternative regarding peak load distribution and off-peak charging would play a significant role in any large-scale design.